Hi, welcome to myprojectbazaar.com. In this video, we'll lead us to complete demo of reliability-based design optimization for cloud migration. Cloud computing is a service-oriented computing based on pay-per-use technologies. In general, cloud computing service requests are based on demand use. Some of the important features of cloud include scalability, which is very high, followed by the low maintenance cost. These factors have driven a lot of customers into storing data on cloud and computing on cloud. Legacy applications from many companies got migrated onto cloud due to its high scalability and reliability. Improving the quality of the service by an enterprise is the major concern. Thus, formulating an efficient and reliable way of migrating the legacy applications onto the cloud is critical. As a solution to this problem, we use the reliability-based migration framework. In our technique, we provide high reliability and fault tolerance using two ranking algorithms. The former algorithm works on the principle of ranking all the components present in the application be moved onto the cloud. The later algorithm works on the principle of ranking only part of the application component should be moved onto the cloud. Both this algorithm utilize structural information of application and historical reliability information for component ranking. Based on this results, an optimal fault tolerant strategy shall be selected for the most significant components. Next we are going to see the flow of this process. For this one, first we need to collect the components from the distributed. Here I have to get that input components, then parsing that file, then integrating that components presented in each file. In the individual component analysis, we will making to computing that frequency of component. After that component placement, we have to computing that weights of computation. This weight computation will computing that each tools presented in many of that component. That vector computation will help us to computing that ranking for components. This vectors will taking a weight as input and computing that some manipulations and providing that ranking components. The ranking components will follow two methods: hybrid component ranking and structural component ranking. Hybrid component ranking will focusing on all the components presented in that components, and the structural component ranking will only focusing on some set of components moving to the cloud. The recovery block will help us to, if in case of fault rate are covering the migration time. The end versioning program used for computing this recovering blocks. After completion of this, we have to analyzing that cost for our inputted job with that particular duration. We can get the set of components accessing with our minimal cost and that minimal duration time. Next we are going to see complete demo of cloud migration in fault tolerant component ranking. For this one, first we need to run home1.java, as well as we need to run that server page as home.java. In this one, first I have to choose in that login option, then I have to providing that login. Before I am getting login, I need to start that server. Now server will getting started. I have to log in to my account. Login successfully. Then I have my profile details. In this account, I having that one option uploading. In this uploading option, I have to submitting that component list. For that one, I have to move to my current folder. In this one, I have to choose one folder which is containing that input files. Then I have to click open. Now that overall document cost was 97.5 and overall size was 13 KB. After I getting this, I move to that server page and click receive option. Then I move to that user page, then uploading that files to server. each component file will getting into server. After submitting this server, we have to click that component list. In this component list will containing that all the components presented in that SQL. Then I have to load this SQLs. For this one I have to viewing that components which I am loading. This will showing that each set of components for particular applications. This is the connection scenario between that components. Then I have to submitting that any one of applications. So I have to choosing that individual groups from this application components. After getting this, I have to computing that weight. So weight will showing that frequency of each component. I have to getting any of the elements. Then I move to next. I have to build the rank option. So now that components are ranked successfully by using that vector computations. So here we have to showing that each component vector values and their main applications. Here we have to choosing three kind of applications: Paint, Photoshop, text editors. Then I have to applying the checkpoint mechanism to computing that fault rate. For that evaluation button, I have to applying that each component will be a critical or non-critical. Critical process is that a user application will get quite complexity. Then I move to next frame. I have to applying that ranking for each component. Here I have to using two kinds of ranking: structural based ranking and hybrid ranking. The structural ranking and hybrid ranking will showing that each component ranking presented in every components. And that hybrid ranking will contains the component characteristics as well as that critical and non-critical status. After this I have to choosing that hybrid component ranking list based on that vector value. In this one will containing that each component applications and their vector values as well as the status of that component, which is critical or non-critical. After that I have to applying that structural based ranking. Structural based ranking will showing that each component rank plus vector values only. It may not considering that status. It may be a critical or non-critical. Then I have to applying that k value for any one component. Here I have to providing that value as 4 and displaying that component. This will showing that the value below that component. After I choosing this, I have to move to next process. Then this is I have to enabling that self-healing mechanism and probability of component failure. This will used to help us to computing that failure rate between the components. After that failure rate computation, I move to that next option and generate that fault tolerant values. In this one we have to showing that each component failure ratio and our recovered block. After computing this, we have to selecting an application to getting that our concept. So I have to choosing that application as Photoshop and viewing that components for this Photoshop. After this I have to providing that cost when I record and how much time I record. After I getting this, I have to submitting this to server. So in between my cost and my particular time, they will showing that number of candidates will be selected by using that optimal fault tolerance strategies. From this one we have to designing that reliability based design optimization for cloud migrations using component fault ranking. Thanks for watching.